All right, let's get started, everyone. Thank you so much for tuning in and welcome to today's Textile Talk. My name is Amy DiPlacido and I'm the curator of exhibitions at San Jose Museum of Quilts and Textiles. I'm excited to introduce artist Helen Remick and design researcher Samantha Shorey as today's Textile Talk speakers. Textile Talks is a weekly virtual lecture series presented by 6 different fiber organizations each Wednesday, including the Studio Art Quilt Associates, the International Quilt Museum, Surface Design Association, Modern Quilt Guilds, Quilt Alliance, and the San Jose Museum of Quilts and Textiles. Today's presentation and Q&A session will last about an hour. So that we can continue to offer these talks for free, I hope you'll consider making a donation or become a member of the presenting organization. I'll put a chat in the link in the chat, or you can visit the SJMQT website. Please use the Q&A for questions, chat box for greeting others, and the post-event survey for commentary and constructive feedback. If you prefer not to see notifications from the chat, you can click on the chat button to toggle them on or off. We respectfully ask you to be courteous as you engage with speakers, moderators, and other participants. We are proud to be supported by the following organizations and businesses who make our weekly lecture series possible: Aurifil, Handy Quilter, The Quilt Show, Misty Fuse, Artistic Artifacts, Schiffer Publishing, E-Quilter, Moda Fabric and Supplies, 9 Patch Fabrics, Empty Spool Seminar, Quilt Mania, and C&T Publishing. I'd like to share some exciting events coming up at our museum. This weekend, we celebrate our public reopening with new exhibitions, including the 13th iteration of American Tapestry Biennial, Stars and Stories, American Art from the Permanent Collection, and Dominguez Hulk. We have a virtual workshop with David Owen Hastings, where participants can learn how to make abstract mid-century inspired mini quilts. We also look forward to working with our artists in residence, Corinne Okada Takara, on a series of bio-quilt workshops in the San Jose community. To learn more about these events and to register, please visit our website, sjquiltmuseum.org. We'll also put our website link in the chat. And now I'm delighted to introduce today's speakers, Samantha Shorey and Helen Remick, who will be discussing their work on the Core Memory Quilt, a project inspired by women's historic contributions to the Apollo space missions. The quilt was produced through a collaborative project at the Tactile and Tactile Design Lab at the University of Washington and was featured in the Center for Crafts 2020 exhibition, The Computer Pays Its Debt: Women, Textiles, and Technology, 1965 to 1985. Helen Remick is a retired university administrator, award-winning art quilter, and an active member of Contemporary Quilt Art Association. This project combined her interests in women and work, women in science, and quilting. Samantha Shorey, PhD, is an assistant professor of communication studies at the University of Texas. Before coming to UT, she was a fellow at the Smithsonian's Museum Lemelson Center for the Study of Invention and Innovation. Today, Samantha and Helen will be sharing more about their groundbreaking projects. We are so excited to have you both here today. Welcome, Helen and Samantha, and take it away.
Hi, everyone. Good morning. Go ahead and share this here. So as Amy said, I'm Samantha Shorey, and I just want to begin by thanking Assistant Curator Samantha Lyons and Head Curator Amy DiPlacido and everyone who supports the San Jose Museum of Quilts and Textiles, and especially all of you for attending today. It was so fun to see all of your locations feed into the chat, and I'm really excited to share this project today through the talk series, Textile Talks. Today, my collaborator, Helen Remick, and I are going to be sharing the Making Core Memory Project, which we created with Dr. Daniela Rosner and Brock Kraft at the Tactile and Tactical Design Lab at the University of Washington. Helen is really the hands and the heart behind the quilt. So we'll spend most of the time today hearing from her about her creative process, working with E-Textiles, electronic textiles, and some other projects that she's done with unconventional art quilting materials based in technology. But to start, I'm going to introduce the project through a little bit of the history that inspired it. So when we think of the Apollo moon missions, we often associate them with a few key individuals, figures that are the mission's most visible symbols, figures like astronaut Neil Armstrong. But this engineering achievement was actually the product of over 500,000 people, many of whom go unnamed and unnoticed in the historical record. Within this unsung network of collaborators are the women who carefully handmade the computer memory for the Apollo guidance computer. And they used a process that was extraordinarily similar to weaving. The NASA engineers called this process the LOL method, for the little old ladies who did the work. But in popular accounts and historical data about the Apollo guidance computer, the little old ladies' material contributions remain largely absent. Rather, these histories tend to focus on the intellectual work of the NASA engineers. The missing stories of the core memory weavers mirror a larger pattern in technology narratives in which women are decidedly absent. For example, this is an image carousel when you Google the term famous inventor. These screen caps are from 2019, but I checked on this before giving the talk today, and you'll see more than 30 photographs of men before you see a picture of a woman. But women, and especially working class women of color, have always done the work that is often considered low status and material that's just below the surface of discovery. Women measured the brightness of the stars at the Harvard Observatory. They manufactured computer parts at places like Philco, Raytheon, and Fairchild, and they produced the first computer programs for the ENIAC. However, the managers' accounts, which make up the bulk of historical data, often frame this work as kind of secondary or menial to the accomplishments. This devaluing of people in the scientific periphery results in their substantive contributions being overlooked and minimized in a way that excludes them from the historical record and also diminishes perceptions of women's engineering know-how and insight in the present. Being able to tell these stories is so important because it makes women's contributions to science seem enormous and ever-present, rather than just novel. For example, this here is a screenshot from some promotional footage that's archived in San Francisco's Prelinger Library. It was produced in the 1970s about the work that Raytheon had done for the Apollo moon missions, and it is brilliantly titled Threads of Technology, which I'm sure this audience loves. And you can see here that in the front of this frame, the focus of this shot is actually this group of all male decision makers right here. But if you look just beyond the focus of the frame, you can see that there are women everywhere hard at work transforming a technological vision into a reality. So before I hand it over to Helen, I'm going to share a little bit about a particular technology, core memory, which inspired our quilt, and walk you through just kind of a little bit about the technicals. We won't go too deep today. We can, of course, cover that in Q&A, but I just want to share some historical details about the production process, that produced these technologies. So at the outset of the Apollo moon missions, computing still mostly relied on what was called punch card technology. These room-sized machines that you can see in this picture here were large, and they weren't very well suited to a mission where minimizing the size and the weight of every component that was a part of the rocket was absolutely essential. Traveling the moon would require that the engineers at Apollo and at MIT and in collaboration with Raytheon produce a really new and novel, light and compact form of information storage that could survive the potential of power loss during the mission. Core memory, the technology that inspired our quilt, met this challenge by storing information permanently on folded beaded ropes that could fit in the cone of a rocket. The software programs for the Apollo guidance computer were permanently stored through a type of computer memory called core rope memory. And so you can see the programs here on the left with programmer Margaret Hamilton, and on the right is a picture of the core rope. And you can see in this picture just how densely these wires were woven together, really allowing to achieve the technical accomplishment of this dense and light information storage that they needed. Core rope memory stored information through what we would call a physical distinction. Most information for computers, even today, is made up of ones and zeros. It's called binary code. And for core memory, this binary code, the ones and zeros, were created by the presence of a wire. If a wire passed through one of the cores, it created a 1. And if it passed around the cores, it created a 0. Sometimes alone and sometimes in pairs, operators made core memory by passing a needle back and forth through a matrix of ferrite cores. The pattern was determined using a machine that would automatically select the core that they were supposed to thread in sequence. The operator would thread the core, press a button, and thread the next, creating a pattern that comprised the software program. The Apollo moon missions also relied on another form of core memory to electronically store the data for the software programs, and this memory was erasable. This even smaller form of core memory was carefully strung bit by bit in a process that was similar to beading. It's this type of memory that is most closely represented in the Making Core Memory Quilt we're going to share with you today. Both of these technologies were united by textile metaphors when they were introduced. For example, you can see here, these are both images from press kits that were produced during the mission to celebrate the work of a space-age needle worker that you see on the left here, and to explain the way that more than 8,000 cores had been strung by hand, and we hear that stringing, that very textile word, to produce the core memory planes that were used for the IBM computers on the ground. So through this project, we really hope to challenge some widely held conceptions of technology that see the work of women in craft practices, which are historically performed by women, as old-fashioned and antithetical to engineering. This little screen cap here is from a comment on one of the historical clips that's posted on the internet from someone who cannot possibly imagine that something so incredible as the Apollo moon missions would be achieved by something like craft and through the work of women. And so I've really enjoyed participating in this project because I can feel in this artifact that Helen has created for us, all of the ways that these these ideas are being brought together and experienced through everyone who interacts with the quilt. So on that note, I'm going to hand it over to Helen here. Let's see here.
I became involved with this. Thank you, Samantha. I became involved with this when I received an email from Dr. Daniela Rosner asking me if I would be interested in developing a quilt of some kind to do something which we didn't quite know yet. It was very open-ended. And I'm an art quilter. I'm precise in what I do. I like to plan out what I do ahead of time before I take a single stitch. And this was going to be something very different. It was to be collaborative, unknown, and fun. We got together, and the first decision was easy to make. There's only one pattern to use for a quilt about the Apollo mission, and that would be Trip Around the World. This is something I did many years ago as a gift, but illustrates Trip Around the World. And one of the things that Daniela showed me when we talked about this was a core, a memory core. I loved it. I was fascinated. This is 4.5 inches, lightweight, delicate, and I had no idea what it was doing. Just no idea at all. There are connectors of some kind on the edge, and some intricate pattern in the middle. So I took a picture and made a close-up of it. And Sam, the close-up. This is about 1.5 inches in reality. And you can see that this is made up of tiny beads. They're about 1 millimeter in size. And each one has 3 wires through it. One is vertical, one is horizontal, and the other is diagonal. And they're in an obvious pattern. This is a grid work, and these are ferrite beads. Ferrite is an iron compound. And the two main vertical and horizontal wires through each bead allows each bead to be individually addressed as part of the grid. So the one in the upper left-hand corner would say, we could call it A1, could be turned into a plus or a minus, a 1 or 0, by sending electrical currents through it or not. Each bead in this was individually addressed. And then this core became a permanent part of a program. I wanted to know how it went together. So I made a model of it at home with supplies on hand. I made a 4.5-inch core from foam board, and then wanted to figure out exactly what the weaving pattern was to make it. And I found that one could do this by running horizontal lines with threading exactly the number of beads you wanted to have on it, anchoring it at both ends. And then to run the vertical line, one had to enter the bead first from the left, then from the right, the next one up from the left, right, alternating all the way up. And then in the next row, do just the opposite, start with right and left. And it caused the beads to go on the diagonal, as you see. Then when you went to put the third wire in, it was easy because each line of beads was properly lined up to slip easily slip the thread through it. My model inspired the next piece of this project. I think Sam did a lot of the head work on this, of making a kit. One part of Daniela's philosophy for teaching is that people learn better if they are doing something while they are listening. And that led to the development of what we call patches, but a kit that we put together for each participant in the talks that were given. So it included a frame made of hardboard, beads, some yarn, plastic needle, and a switch. People and instructions. And during the talk, then, people in the class were able to experience what that weaving was like, how it had to go on. And they then produced something in that fashion. Now you'll notice on the hardwood frame, we also wondered, how would we attach these to the quilt? There had to be some way. And I remembered that years ago, for reasons of curiosity as much as anything, I had bought a set of magnets that to be used to close a woman's purse. And we put these on the corners of the patches so that the patches then could go on to the quilt. Well, that led to another thought, which was, if we were putting the patches on the quilt, why didn't we wire the quilt? And in so doing, could we then make use of all of the audio clips which Sam had been collecting during her work? So we got to the patches, and then, the switch. I love this switch. It's perfect for use on fabrics. So I'll take a minute to talk about exactly what the switch does. This is felt. Ours were laser cut, but one can hand cut. To wire it, to make it have electrical connections, we used a tape that you can find in a gardener shop, designed to discourage slugs and snails from going in your garden. Online, I found that it doesn't do that, but it was just right for what we were doing. A length of that, of copper on one side and an adhesive on the other, would make our electrical connections. One piece was threaded through, as in the second image here, with the copper side up. And then the second was threaded through with the copper side down, so that when you press in the middle, you would find that the two copper surfaces would touch. And if electrical current were going through it, that makes the connection. Now, one end of each of these strips was then connected to one of the magnets on the patch. And that made this made a switch which could go on, off with the patch, and an electrical circuit. We'll talk about it in a minute. And next. Here are some finished patches. You can see the white and copper lines going through them. The participants had varying degrees of skill. The one on the right, center right there, is very neatly done. Some of the other people were less skilled. For the most part, you could tell who the crafters were. Women in the talks took to these kits, loved them, made nice, neat ones, and especially some of the men were absolutely baffled by the idea of stringing anything through beads, let alone making a nice pattern out of it. Now we have an example next of one of the patches going on, and Sam is going to play a clip. Perhaps. Sam needs sound.
Doors with wires woven in and out, sewn in with a pattern. Where the information here is in the pattern of the sewing. Let's see.
So these clips were from her research, often one man in one of the clips talking about the LOLs, little old ladies. Now we're going to talk a little bit about electricity. You cannot have a grid without knowing a little bit about electricity. The quilt was a pattern, a trip around the world that we made was a 7x7 grid. Each square in that grid needed to have a unique address in order to make this design work. I'm using a 3x3 here for reasons of simplicity. So every square in this grid can be identified by its column address and its row address. So A1, C2, B3 are unique addresses for this. Now we're going to add wire. So if we add the vertical wire, the circles represent the magnets. We would run a vertical wire and in each column and connect those to a power source. Then when we add the horizontal wire, we run those across and down to a power source. Now there's electrical notation here. You notice the arch over the green wire. In electrical notification, that means that the wires cross, but they do not touch. If they touched, that would short out the circuit. So the wire does cross, but doesn't touch. And finally, if we add more electrical notation, the blue represents the electrical notation for a switch. And this is saying if we have a switch and we close that switch, that closes the circuit. It makes a circle of wire. So I highlighted in yellow the circuit for A1. That's a unique circuit. If you close any of the other switches, it will use a different combination of the column of the horizontal and vertical wires. Now we'll look at, this is quilt 1. Yes, there were several quilts. I had to try something and each one had to be better some way. I had to add something or try something different. The quilt had to be sturdy. It had to be rollable. It had to have things hang on it. It had to be substantial enough to poke the holders for the magnets through it. It had to be flat on its surface. I used fusing as the method for making it because piecing would have left bumps. I am not a fuser, and I can best say that mistakes were made in this process. To wire it, I had a special electrical conductive thread that Daniela had. It was an experimental project, so it's not readily available, but I could sew with it, but only using it in the bobbin. Now, to make the circuits of the horizontal and the vertical wires, it was necessary to have some kind of insulation wherever the wires crossed. I chose with this one to use the model of microchips where you have a layer in between. That is, I sewed the horizontal wires on the front of this, and the vertical wires were on a piece of fabric behind this face, so that the fabric itself served as insulation. The trick for that, of course, to put the wire on the front surface, I had to sew it from the back. So this had to be carefully marked on both sides of the front sheet. In addition, every time it was the place where I needed to make a connection to a magnet, I had to make a long loop of the thread. So I'd have that to make the connection, then sew, make a long loop, etc. Now on this close-up, you can see the horizontal thread going across. You can see it most readily on the orange squares. And then on the right-hand magnet, you can see where the thread came up and was wrapped around the magnet to make the connection. Then there was quilt 2. This is in process. Again, with fusing on the surface, I made a couple of design decisions on this. One, we realized that for the quilt to be used for teaching, it made no sense to have the wiring hidden behind the surface of the quilt. If you're teaching people about circuitry and about what you're doing, you put it on the front. So all the circuitry needed to be on the surface of the quilt itself. We also designed, you see a circular part on top. We made a circle out of hardboard and mounted all of our equipment, electronic equipment, on that board. There are a couple of reasons for that. The main one being then you could disconnect and lift it off when rolling or transporting the quilt, protected the electronics. It also was the interface between the softness of the quilt and the wiring, the thread of the quilt, and the hardness of the devices, electronic devices. That was a difficult connection to make. I also made the artistic decision to put the horizontal wires on the diagonal. That is a violation of grid work. You shouldn't do that. One reason that this demonstrates is that it is inefficient. On the grid that was made with a 7x7, there were 14 wires that went to the electronic connection. This one with the diagonal is inefficient, and there are 20 wires that were needed rather than the 14 before. So Brock Kraft, who was doing the programming, was not pleased that he had to add some more clips because of my artistic flair there. Now, what you see as the wiring on that is not actually wire, it is yarn. I couched yarn onto the lines where the circuitry would go. And then afterwards, I threaded the conductive thread through the yarn. So the yarn did two things. It made the circuitry more visible, and it protected the thread. We had trouble with the thread. Sam was usually the one who had to find where the circuit had broken, and but with this approach, with it on the surface, it was easier to patch broken circuits. And the finished quilt is here with all its patches, with the circular board. The little bit of orange you can see on the bottom of the circle were mechanical connectors where we could put in wires from the circuitry on the quilt into the board. And in the circle is an Arduino microcontroller. That device there, which I figured out, if you're making something with wires and you want it to be connected to a computer for the audio clips, you can't simply run wires over into your computer. You can't just plug it into your computer. So the Arduino device is something where you can take straight electrical wires and put it into something that changes that straight wire in there to an electrical signal that will be compatible with computer or the device. If we were not doing the tweets at this point, you could bring those wires together in some way to an electrical source directly. Then there is Quilt 3, and this takes another aspect of quilting itself. In this one, I designed the quilt on the computer, drew the quilt, colored in the squares, drew on where the circuits would go, this time going back to a 7x7 grid, and then printed it onto cloth. So this is a printed circuit in a sense. As the last step, Daniela had some special multi-strand, very fine wire that I sewed to the surface of this quilt, following those circuit lines. I don't have a finished picture of this quilt. About the time we were finishing up with this project, Sam got her job in Texas and left. Daniela went on a sabbatical to Germany and got stuck with the pandemic in Germany, and the University of Washington closed its doors for a while. So I'm sure this quilt in finished form is at the university somewhere, but it was not possible to get it for pictures. And that is how you make a wired quilt in several different versions. Now, this was not my first non-traditional quilt. Some time ago, I made one. I thought a lot about technology and how it changes. And so this is the first of three where I was exploring different kinds of technologies that are obscure. In the 70s, sometime a friend, an engineering friend of ours, talked about how on one of the early missions, a lot of pictures were taken of the backside of the moon for the first time. It was really important. And just a few years later, all of that information was absolutely inaccessible because the computers that would read that particular set of data no longer existed. And so we lose data all the time from changes in the technology. And this was about CDs. By 2010, CDs had come and were about to go. It was not a good way to collect data. And so I took CDs on which I had collected pictures, family pictures and the like. And the dull one on the right, third down on the right column, is an AOL CD, for those of you who are old enough to remember that period of time when in the mail constantly we got AOL sent out CDs to introduce you to its services. This quilt is very, very sparkly. It was difficult to photograph because it was so sparkly. I would also say on the CD side here, this has been stored nicely flat in my basement since I made it. Some of the CDs are now peeling and a couple have cracked, demonstrating that CDs are not such a good deal. On the back side of this quilt, I took images from those CDs and a few others and showed what would be lost if one hadn't transferred the data. So there are pictures of some of my quilts, story, a family story my dad had written, pictures from a trip to France, my grandchildren, all the kinds of memories and things that are lost when we don't keep up with the technology. The next quilt has a similar theme. I was cleaning up boxes of pictures in storage, as one often has, and I found all of these color negatives from 35 millimeter film. There are two things I liked about it. The color, the orange color was just wonderful. And secondly, that there were all these convenient holes down the edge that I thought reminded me of quilting in some way. So I took those negatives, first transferred the images as best I could to electronic form, and then made prints of those parts of those pictures and other electronic pictures I had, printed it on overhead projector film sheets, which is yet another form of obsolete technology. Nobody uses an overhead anymore. So it was easy to get lots. And I cut out pieces of the CD. I designed the photos into the right size, and I have a machine that cut them in the shapes I wanted, so that there are images on this quilt, again, of the past. I was also making this at a time that my mother-in-law was slipping into and died from dementia. So the upper left-hand corner was in memory of hers. So the pictures of trips, of people, of important things in my life on this quilt. It looks very good when the light shines through. It kind of glows. On this and the next one, you'll see that I used tulle. When I was using things that light would come through, I found that shiny tulle with little sparkles on it put behind whatever the device was added to the reflection of the lights. I also had lots of slides. Those of you, the slides were king or whatever for a period of time. These slides include my graduation, my prom dress, my daughter eating an ice cream cone on the beach. Lots of memories from a very select period of time when slides were everything. Slides are now obsolete. Most people no longer have, fortunately, most people no longer have slide projectors. And if they do have one still, they don't have a bulb for it. So this is a technology, a way of remembering things, sharing memories that is just totally obsolete. This I used an art tape. Well, I was going through some old records of my quilt organization and came across all kinds of slide holders from back when slides was how we took pictures of our quilts to send into shows. And there were 8.5 by 11 holders. So I sewed those holders together. And then I colored photographic paper to get exactly the shades I wanted, then cut out a frame for each slide. So the slide holders here are holding a slide with a frame, colored frame in front of it. And then it's lightly quilted to a back. So it is technically a quilt. And I think that's what I would like to say about quilts.
Great. Thank you guys both so much for that riveting presentation too. And while you guys were speaking, I'm thinking, coming as a textile enthusiast and curator, you guys touched on so many different points like gender, labor, even how the medium holds a sort of memory through the human touch. So I'm just curious, what happened in the late 1970s then for computer programming to shift from women-dominated work to now male-dominated? Did something happen?
Sam?
Yeah, the kind of quintessential work is on this exact shift. This is an amazing question, Amy, is a book by Mar Hicks called Programmed Inequality, which actually traces the computer industry in the UK, but a similar shift happened in the United States as well. And basically this work that had been really feminized as the work of women, computer programming, computer parts manufacturing. Computer parts manufacturing also becomes increasingly racialized and is sent kind of offshore, where a lot of computer components are still made today. The parts for your iPhone, for example, are made largely by Asian women in places like Foxconn in China. But when it comes to computer programming and what ultimately becomes really high status work in places like San Jose and San Francisco, is a really concerted effort in order to reframe this work, which turned out to be, a booming industry in the United States, a great source of jobs with benefits, with increasing prestige as science, technology, and engineering play a bigger part in the post-war economy. There's a concerted shift basically that takes place in the United States that promotes men to managerial roles and reframes this work as scientific rather than technical. When women were doing programming and literally plugging in switches, like a switchboard operator would have for computers. It was seen as technical and physical and kind of menial and repetitive. And then the discourse around this work changes to making it something that's creative, fun, requires a bit of risk-taking. And so it's really a discursive or narrative frame that changes around this work. And then different people get assigned or get seen as being ideally categorized for that job. And we still see that today. Certain types of words in job postings like, you know, like media maverick or a self-starter will glean certain types of applicants other than others. And so this shift occurred in the 1970s as well.
And similarly, there's the maker movement that is in parallel to the textile renaissance, if you will. How do these two different groups interact with the Core Memory project, and how are the reactions different or similar?
Yeah, the maker movement is something that definitely overlapped a lot with this project, especially in our interest. The switches Helen shared, for example, were cut on a laser cutter in the maker space at our university, and the patches that Helen designed, we had prototyped them initially with these kind of foam core frames. And Helen was very good with the X-Acto knife, but mine were a complete mess. And we thought, okay, if we're going to be able to scale this or invite other people to participate, how are we going to create more of these in a way that is efficient and accurate? And we used a laser cutter for those as well. And within the kind of larger maker movement, there's this resurgence and really excitement for the kind of work that many of you are doing with your quilts, with your textile work. Anyone who is creating things by hand, because of the way that this handwork, or what Helen always reminds us, isn't just handwork, it's neck work, it's back work. When you're making a quilt, you're on all fours, getting everything just right. It helps us think about things differently and understand things differently. And that's one of the things that Helen talked about in her talk, was about the way that this has been used for a teaching tool. But within the maker movement, of course, there are these similar kind of divides that we see happening again and again, where the technology is seen as the, Arduino, the computer chip that we talked about. Let's see, it's up here. These very, clearly computer components. And then all of this down here isn't necessarily making it, it's craft. And so that was one of the things that we were really seeking to kind of entwine through a project like this.
Yeah, interesting. And how did you choose to add the tweets or the connection to Twitter with the Arduino?
I don't remember how that happened. Helen, do you?
Oh, Helen, you're muted.
Spontaneous came out. Our sessions were wonderful. I mean, ideas just flowed. We get together every couple of weeks, and I'd go home with some part of the quilt to add something else or try something else, and we'd come back together, and our ideas would just evolve. It was wonderful. Very exciting.
Yeah, we have a question asking about who designs the core memory strategy in the first place, and how were the circuits tested to be sure that the diagonals worked?
I'm not quite sure. We had an ammeter. We put a probe on each circuit and checked it out to see whether it was working. It was time laborious. You had to check every single circuit every time to see if it worked. And I believe that Sam had developed another little square device to be sure that in the patch itself, that was a complete circuit. It was something connected with a battery, so that you could put it on, push in the middle to make sure your patch was working.
Interesting. And can you guys talk a little bit about how you both met? And Sam, how did you find Helen? And Helen, how did you agree to take on this kind of project, seeing as your personal work resembles this?
Oh, it's fortuitous. It was just an amazing experience. Daniela asked in a meeting someplace if anybody knew a quilter. That person gave my name. She sent me an email. I got there and Sam was already with the project, so she'll have to answer that part. And I brought my interest in science, my interest in women's work, my quilting together. It was wonderful.
And how did you guys both decide to land upon a quilt too, as opposed to something else in the fiber art medium?
Daniela liked, in earlier projects, had worked with women and crafts, and somehow she had an image of a quilt without knowing quite exactly what it would work. So we had to start from a vague idea what a quilt is and make this. It was amazing.
And can you guys talk about why having the interactive portion was so important to you, and also who was the youngest participant in those workshops?
Sam?
We've hosted quite a few workshops, and a couple of people have, in the ones that we've hosted, have actually brought their children. And so we've had people that are 8 or 9. We hosted one at a Maker Summit in Washington, and there was quite a few parent pairs. And so it's really exciting to see the range of people that have participated in this project, from 8 or 9 years old all the way to when we hosted this at the Computer History Museum in Mountain View. We had some of the engineers who had actually worked on the Apollo attend, and so they were, closer to their 80s. And so being able to incorporate such diverse experiences was really exciting for us. And our group of collaborators also are multi-generational, and was something that I really gained a lot from. We had undergraduates working on the project, master's students. I was getting my PhD, and Daniela, who was a next generation scholar, and Helen, who had an illustrious career at the university that had really been completed by the time that we started working together. So the cross-generational nature of this project was really terrific.
I agree. I had a wonderful time.
And if there's any advice that you would give to people in our audience who are really curious about starting technology in their artwork, how would you recommend, or what advice would you give? Conductive thread first?
Well, that's the hardest thing to get. I think learning to use wire, I'm looking for a source myself to see, because I think I must have to do something else to get a flexible wire. You need something flexible to do it. And the Arduino appears to be necessary. It's advertised as being easy to program, easy to use for all kinds of crafts. That's something I need to look into a little more too.
Great. And any upcoming creative projects that you guys would want to share with our audience?
I'm waiting for the next idea to come. So
I'm in that I'm in that generative space as well. I've been thinking kind of through crafting and the history of cryptography, and the way that so much of the textile history has also been implicated in codes, literal codes, hiding information, something that's kind of been inspired by my collaborations with Helen as well. And so I'm looking forward to the post-pandemic moment when we all experience a creative resurgence, right? Fingers crossed. I know many of you guys are probably there as well.
Yeah, and speaking of the time after COVID, will people still be able to touch these the quilts to get the sounds? Do you know?
Sure.
Like if it's shown at a museum?
I think it will. The next exhibition we'll have will begin in January 2022 at the Tang Museum at Skidmore College on the East Coast, and the patches will be installed there, and I assume open for interaction. I don't know. I guess I'll have to talk to you, Helen, about the sanitation and how they'll.
Yeah, I'm not concerned. So.
Yeah.
Copper is antimicrobial, so yeah. I think there's a couple technical questions here. Do we have time?
We have 3 minutes left.
Helen, do you think would florist wire work? Is it conductive?
It'd be worth trying. Yeah. It just needs to be wire. I mean, it just, anything that is metal will conduct.
Right. Well, thank you again for this presentation too. We have a couple of slides that we would like to share at the very end. Samantha and Helen, this has been so great. I just want to thank our sponsors again too for supporting this event. We'll be sharing this presentation on YouTube and Facebook after, within 48 hours, hopefully. If you enjoyed this talk and would like to donate or become a member of SJMQT, please visit our website, sjquiltmuseum.org. Please join us next Wednesday for our next presentation with the Modern Quilt Guild. We look forward to seeing you then. Take care, everyone. Bye-bye.